everyone. My name is Stephen Dwyer, and on behalf of everyone here at Civision, I'd like to welcome you very much to today's webinar. We're privileged to have with us Peter Datacenter, who's a Microsoft Infrastructure Architect, Microsoft Certified Trainer, and also a Microsoft MVP. And not only is he presenting today's webinar, but he also put together the companion white paper that's available for download from our website. If you have any questions during the course of the webinar, please feel free to write them in the Q&A window, and we will get to them at the end. And without further ado, I'm very happy to turn things over to Peter.
Stephen, thank you for that. So to my audience, welcome in the session. For some of you, I could say good afternoon or good evening for the European ones. And maybe you're even connecting from somewhere else in the world. So wherever you are, thank you for being here. So in this session, I'm going to talk about Azure Site Recovery and mainly focusing on how it can help you in building a Hyper-V disaster recovery solution. Now, already for your information, the Azure Site Recovery is not just for providing a disaster recovery solution for Microsoft platforms only. So it also allows you to secure servers in Azure that are running on premises in a physical way or even on a VMware platform, but more on that later on. Now, to make sure you understand the full topic of the session, I'm going to start with a short introduction on disaster recovery as such, followed by specifically Microsoft disaster recovery solutions as we know them, I could say up to today, and then quickly jumping to a more deep dive Azure Site Recovery walkthrough. So making sure that you understand the basics of the solution, and even by basics, after showing you the demo, which would take close to 20 minutes, you will actually find out that it's almost possible in creating a full production-ready site recovery solution, even within 60 minutes. And then we're going to go back to Civision Live Maps. So the main sponsor of the webinar and the provider of the companion white paper, by quickly showing you how their Civision Live Maps Unity tool can actually allow you to do full end-to-end service monitoring, service management of the on-premises environment, as well as the Azure backend components. So a couple of words about myself. I know you're here for Azure Site Recovery, but I also understand that most of you want to know something about the guy who's actually doing the presentation. So as Stephen mentioned, I'm mainly working as a Microsoft Infrastructure Architect, although I'm still pretty active in the hands-on deployment as well. I've been a Microsoft trainer for about 10 years already, and an MVP for 3 years, of which 1 week on Azure. So I was an MVP on Windows IT Pro for 2 years, and then in my renewal on October 1st, I actually jumped to the Azure technology focus. Besides that, I've been writing a couple of Microsoft technology books in the past, and providing webinars and speaking at conferences with a live audience. And because I really like community work, together with a guy from the Netherlands, actually by coincidence, we somehow bumped into each other wearing yellow pants at a Microsoft conference in Madrid 2 years ago. And somehow, we had the same passion, the same experience within Microsoft technologies, the same passion for Microsoft events, and the same passion for Microsoft certification. So we decided to create our own small community, which somehow got adopted by the marketing folks from Civision, and we actually organized a party at TechEd Europe last year. So with that, again, community is important. I want to spread my knowledge, my experience, like for example, during this webinar. So I just want to ask something back in return. So if you're live on Twitter, don't hesitate to send out a tweet mentioning my tweet handle PDTIT, mentioning Civision and the Tag at Yellow Pants team, and in return, I'll provide you a free Hyper-V book. And it's not enough for just providing stuff. Last week, I actually published a full 2-day online training course together with the guys from Obsgelity, which is one of the Azure recommended training sites. And I told them that I would do a webinar on Azure Site Recovery, so actually the main topic of the Azure course that I wrote for them. And they provide you a 30-day free access based on a live subscription for a year. So if you sign up, I think it's close to $29 per month, then they actually provide you 1 month for free if you're using the OPS code. And then, as already mentioned by Stephen, there's also a white paper, like a companion to this webinar, freely available as a download from the Savision website. So with that, that was the marketing part. So I'm going to jump to a bit more into the technology and explaining you what disaster recovery actually means. So first of all, when you go out to the business or even within your own environment and you want to convince your management, hey, we actually have to start doing something around disaster recovery, then sometimes it's a bit hard to explain. It's like, disaster recovery, we do have a backup, so we are covered, or is it something else? And then I like to make the comparison with just a light. I mean, everybody knows that light is important. And if it's dark, like here in my location in Belgium, then when the lights go out, it's panic. Like, I don't know where I am. I don't see anything. So people get a bit scared. And then the solution is actually pretty easy. It's a light switch. And then the main solution, you turn on the switch. If all goes fine, then light is back and everything is up and running again. So the same goes to your IT environment, so the full IT stack. Something happens, a server goes down, an application goes down, maybe the full data center goes down, and then you want to rely on a solution. And in this case, your light switch can be Azure Site Recovery. Now, disaster recovery within any IT environment is not something new. I mean, Azure is still pretty new, although it exists already for like 4 or 5 years. But disaster recovery as such, I mean, it's nothing really new. In I could say the old days, like 30, 40 years when the first mainframe computers came live, they already had some kind of disaster recovery solution. Now, when thinking about disaster recovery in a lot of existing IT environments, it's based on replication from one data center to the other, or by using application clustering, or even between 2 data centers, where you can talk about stretched clusters. Then to make it a bit more complex, it can be an active passive failover, it can be an application failover like SQL mirroring, for example, or even relying on storage SAN replication. And if that isn't even already complex enough, then think about stretching your data centers in multiple regions by relying on geo load balancing. So if, for example, one data center, your data center in Belgium goes down, you have a second data center somewhere in, I don't know, Germany, or even somewhere in the US, then you can rely on geo load balancing and actually still having the same resilience. Now, all these solutions that we've known for the last years, most probably are pretty effective, but the downside is mainly expensive. Thinking about storage replication, thinking about internet connections, thinking about even already from a licensing perspective, having a standalone application server like SQL, Exchange, SharePoint, whatever, relying on enterprise editions is already like 3, 4, maybe sometimes 5 times the cost. So there might be another solution available. Another downside is sometimes vendor lock-in. So imagine you have a storage solution in one side. If you want to perform a full disaster recovery setup, then you have to use the same component. So it's not really, or at least not always possible, to have one solution, one vendor on one side, and using a complete other vendor on the other side. And then the last one, and I think this explains why I'm spending quite some time on this slide alone, it's still very complex. And then in most cases, it's like all or nothing. And then taking a view from the end user perspective, again, a pretty basic schema. So we have our on-prem IT platform. Users are in the same offices and they're connecting to the server applications. And then we also might have some remote working users and an external disaster recovery solution, like a second data center, for example. And then users are connecting to the application servers. So the local users on-premise in the data center building and remote users connecting through whatever mechanism we're using. And we do an offsite copy, replication, failover, depending on the solution or the mechanism, to an offsite data center. Then if one of the applications goes down, not really a problem. By using DNS, load balancing, whatever existing solution for the last few years, we're actually redirecting the remote users and the local users to the remote side. And then everything is restored, so no worries. Now, if the main data center goes down, first possible solution might be to again redirect the users to the disaster recovery site. And then after everything is being restored, we just reconnect to the on-premises environment. And worst case, it's not enough to actually recover the on-premises site, but actually moving the users. So by, when there's a flooding, when there's an earthquake, when you're really losing the building. Even at one of my customers a couple of weeks ago, they actually had a electricity outage. And they were it was a planned outage, so they got informed by the electricity company that at that specific date there will be downtime for the full day. Now, machines for them were pretty critical, and they contacted me like, hey, can you provide some kind of disaster recovery? And then after only a couple of hours, I configured Azure Site Recovery, replicating virtual machines, and during the recovery time frame, they actually connected everything out of the Azure data center. And then 2 days later, moved everything back on premises. So for them, even in a planned situation, the Azure Site Recovery was already a solution. Now, one of the reasons, again, without breaking down the existing architecture or the existing disaster recovery solutions, there are a couple of reasons to reconsider. And I hope for most of you, that's one of the main reasons why you're actually in this webinar. So as already mentioned 2 slides back, it's been a challenge, pretty complicated setup and solutions, sometimes expensive, requiring a lot of planning, design, thinking about what happens if my application server goes down, what happens if not only one server, but a couple of servers are going down, what if my full data center is lost? So it required a lot of planning. And then thinking a bit about the future, and actually the near future, because it's already available today, is relying on a public cloud offering like Azure. And again, one of the main benefits of using cloud technology is that it's a lot cheaper. And then just for your information, feedback from a couple of my customers, having a backup plan, having daily backups, full backups, incremental backups, whatever, is not a disaster recovery solution. Although having a backup is already helpful. Or another remark, having a monthly maintenance plan is also not a disaster recovery solution. Although again, it's not really bad having a maintenance plan, but the maintenance plan is mainly used for performing monthly updates on server and applications. And then another one that I heard from one of my customers, I don't need a disaster recovery plan because I have you as my IT guy and I rely on you if something goes wrong. Not the best idea thinking about a disaster recovery plan. So that was disaster recovery. Now, moving a bit further down to Microsoft's disaster recovery stack, it's actually pretty simple. So in any data center or even a server room, and even if you want a standalone Hyper-V server, we have computing components, storage components, networking components. And then on top of that, we have the virtual machines or physical servers. And then at the top layer, we are running our applications. So at the bottom layer, on computing level, storage level, networking level, we can rely on third-party storage replication in the same data center or again between multiple data centers. On top of that, the hypervisor, again talking about Microsoft, we can rely on Hyper-V Replica, the feature of Windows Server 2012 R2 that allows you to replicate virtual machines from one physical Hyper-V host to the other. And then one step further, relying on disaster recovery, high availability even if you want, on the application layer itself. So like SQL always on, SQL mirroring, Exchange database availability groups, where, for example, you deploy 2 Exchange mailbox servers and the databases get replicated from one mailbox server to the other. And then one of the newer features is performing disaster recovery replication by using Azure Site Recovery. Now in this setup, as it's shown here on this slide, we're using Azure Site Recovery as an orchestrator. So imagine we have one data center. We want to replicate our full Microsoft stack to a second data center. Without using storage replication, without relying on Hyper-V Replica, we can make use of Azure Site Recovery as a control mechanism. And then by installing some Azure Site Recovery components in the 2 data centers and some configuration within Azure itself, we can actually almost provide the same solution. So it's a combination of Hyper-V Replica and Azure Site Recovery, and if you want, we also have backups. Again, it's not a full disaster recovery solution, but it will help you. Now, why is backup not the best disaster recovery solution? Because it's still pretty slow. Imagine if one of your servers, your applications go down, then having a backup, of course, is already an excellent idea, but you still need to perform a full restore of the data and the application server. So again, taking some time. But again, if you're already running this kind of setup, that's already an excellent solution. Now, when making the image complete out again from a Microsoft perspective, we can already rely on Hyper-V failover clustering. So a couple of Hyper-V servers connecting to a single storage solution. And then using virtual clustering, so from within the Hyper-V guest application, like again SQL Server or Exchange or SharePoint clustering, whatever. And then going one step further, relying on Windows backup, again for standalone servers or the more enterprise-oriented System Center Data Protection Manager. And then going even one step further is integrating your Windows Server Backup or System Center Data Protection Manager into Azure Backup. So where Azure Data Center, the Azure Cloud Services, are actually being used as an endpoint for saving your backup files. And then, of course, you can perform a full restore out of Azure as well. And then Azure Site Recovery, which again allows you to migrate, replicate, disaster recover servers from any on-premises environment, being a physical one, a virtual one, running Hyper-V or VMware, into the Azure virtual machines. So with that, this brings me to the more detailed explanations of Azure Site Recovery as a solution. With again on one side, our primary side, we can have physical machines. The physical machines need to run server 2012 R2 in this case, or 2008 Service Pack 1, running Hyper-V 2012 R2, and VMware ESX, ESXi 5.1, 5.5, or even 6.1. And then by using Azure Site Recovery, so we configure the Azure Site Recovery backends, we deploy some tools, some agents in our on-premises environment, and the virtual machine state or the physical machine state will be replicated almost real-time directly into the Azure Site Recovery services by using HTTPS. So the data itself, files, folders, application, and the system state itself will be replicated between the on-premises environment and Azure Site Recovery by using HTTPS. Or a second possible solution is not replicating data from the on-premises environment directly into Azure and relying on Azure virtual machines, but actually using Azure Site Recovery as a control pilot, as an orchestrator, and replicating data from one data center, one site, to a second data center. And in this setup, you rely on Hyper-V replica or storage replication, which is being controlled, managed by Azure Site Recovery agents, and there is no data traveling to the Azure data centers. Now, a couple of key features why an organization, SMB, or even an enterprise environment could start investigating Azure Site Recovery. First of all, it allows you, it performs full automated virtual machine protection and replication. So again, even if your on-premises environment is running physical machines, like a server 2012 or 2008, or again running VMware ESX or ESXi machines, it allows you to create, replicate to full virtual machines in Azure. Another thing, and that one will become clear in the demo, is having a full health monitoring environment. So already from within Azure portal itself, on multiple layers, it will actually tell you if something is wrong with the replication, if the machine that is being secured by Azure Site Recovery is in a healthy state or not, and a lot more. And then two other key features is near zero recovery point objective and minimal recovery time objective. The RPO can be lowered up to 30 seconds. So by default, as I will show you in the upcoming demo, when we configure the replication, it will initiate a sync every 15 minutes, can be lowered to 5 minutes, and since the last update, up to 30 seconds. So every machine state from the on-premises environment gets replicated into Azure Site Recovery every 30 seconds. And then the recovery time objective, because your on-premises environment, the state of the machines is almost identical, fully replicated to the virtual machine state. Whenever you want to perform a full recovery, a failback from the Azure environment back to the on-premises environment, there's almost no downtime. Because the machine state is somehow up to date, the replication is still live. When performing a failback, it's only replicating the last changes back from Azure to your on-premises environment, and there's no need to restore the full, let's say, 15 gigabytes of data out of your backup solution. Another interesting feature is replication from Azure and to Azure. So in most cases, customers will actually replicate from their on-premises environment into Azure. And then maybe at some point in time, instead of performing a full failback, they even might decide to use Azure as their primary data center. And then the last one of the most interesting one, according to me, is supporting the mixed environments. So again, Hyper-V, System Center, Virtual Machine Manager environments, VMware, and physical servers. And then think back about the introduction slides on the existing disaster recovery solutions that are working well, high available, performance, between data centers. All that is available, but the downside is that it's very complex and pretty costly to configure. So coming back to the ease of the configuration within Azure Site Recovery, it's literally a step-by-step scenario. Step 1, creating a vault. Step 2, in this case, focus on Hyper-V, creating a Hyper-V site or a VMware site or a physical machine site, preparing the Hyper-V servers by installing the Azure Site Recovery agent and installing a registration key. In step 4, preparing resources, creating a storage account in Azure, creating network topology in Azure. Step 5, creating protection groups, where a protection group is being used to somehow combine your protection mechanism for specific servers. So for example, if you have a couple of domain controllers, a couple of application servers, maybe a few database servers, you can create your own protection groups, like all domain controllers. And then configuring replication of a domain controller is fine for me with the base setting of every 15 minutes. Or you could also create a collection of virtual machines, like 2 domain controllers, 2 application servers, and 2 database servers, becoming part of the same protection group. And whenever something needs to be failed over from on-premises to Azure, those 6 machines will be recovered at the same time. And then in the last step, protecting or enabling the protection for the virtual machines. So again, it's possible to actually configure disaster recovery on a virtual machine level. So it's not on a Hyper-V host, not on VMware host level, although that one is also possible. But imagine you're starting to test Azure Site Recovery. Then you can start with securing, recovering only maybe, 5 virtual machines. And then at the next coming weeks, migrating, upgrading to more virtual machines. And then at the end, after a few weeks, having a full data center disaster recovery solution. And then the last step, testing your deployment, exists in a couple of different flavors. So it's, first of all, allowing you to perform a full non-production impact failover testing. So it will create a dummy virtual machine in the on-premises environment, replicating the data to Azure, starting up the virtual machine within Azure, and then doing a handshake to the on-premises test server, saying I am fully up to date, and now my machine runs in Azure in the recovered state. And then giving you a report like, hey, these are the tests that I've gone through, and everything is up and running. Or even performing a test in a production environment, which can be a planned failover or even in testing an unplanned failover. So this is about the same. So I'm not really going through the same step-by-step scenario again. I think it's more of interest to actually show you in the live screen. But again, how does it start? You create an Azure subscription, you activate Azure Site Recovery Vault, downloading the agent, downloading the registration key on your local machines. And then let me go one step back, then live from the portal. Again, you can see it step 1, step 2, step 3, and so on. So once the agents are installed on your local machines, being again Virtual Machine Manager or the standalone Hyper-V or VMware or physical machines, it will replicate the data, and after a couple of hours, days, depending on the size of your environment, the machines will be available within Azure, and from there you can perform the full failover. Now you've already noticed that a demo is waiting. So with that, I'm going to jump to my test environment, which in this case is based on two standalone Hyper-V machines. They're part of the same domain, but it's not like a full system center virtual machine environment. And I'm running, let me add my other Hyper-V host, which for some reason is not possible. Well, okay, not that important. So I'm running on my Hyper-V machine, I'm running two virtual machines. One of them is my SCOM server that I need in the next demo for showing you the live maps from Civision, and another virtual machine. Then from the Azure point of view, I'm logged on to the Azure portal, and from within the portal, I go to Recovery Services. Now I already did some pre-configuration to make sure that I'm actually capable of going through the full demo. But to show you just how easy it is, I start with creating a new recovery site. I'll give it the name Civision Webinar Azure, or whatever name you want to use, and selecting your region. So the region is the Azure data center location. So I'm in Belgium, so let's connect to the Western European tenant. And creating the Azure Site Recovery Vault. So this will only take a couple of seconds. Or it should take a couple of seconds. And there we go. So now I have my Azure Recovery Site configured. And from here, I can continue with the other steps. It's a bit slow today. Nothing to worry. So the next step would be adding my Hyper-V site or virtual machine site, or if you want, again, a VMware site or physical machines. So I'm going to create a Hyper-V site, and I'll name this one Belgium because that's where my data center is. Now again, a Hyper-V site is like a logical object allowing you to just nominate your locations. So there's no integration with IP, subnets, physical locations. It's just a logical collection of Hyper-V servers. But in most cases, you just classify it as your data center location. So creating the Azure Vault, creating the Hyper-V site, which is something that I already prepped. Although it's just taking a couple of seconds, I didn't want to wait for it. So step one is creating the Hyper-V site. I already did. And then step two is downloading the provider. So it can be considered as an Azure Site Recovery agent, and downloading a registration key. A registration key is your security and connection mechanism from the local Hyper-V host to the Azure Site Recovery Vault specifically. So again, to speed up the demo, I already installed the agent, so it's just the next finish install. And the next step is configuring my site recovery. So as you learned from the slides, Azure Site Recovery relies on direct HTTPS connection between the host and Azure Site Recovery backend. And in the first part of the configuration, I specify the internet connection. So a direct connected server, or if you're using a proxy server in the network, then you can provide proxy settings. And then the next step is importing the registration key. By importing the registration key, I can verify it's linked to this specific subscription. which is in fact your Azure, the overall Azure subscription. It's linked to this specific vault and to this specific Hyper-V site. So again, if you have multiple sites, multiple Azure recovery vaults, then you just have to download specific registration keys for each and every vault or Hyper-V site. If all goes well, it will contact my Azure backend, again by using encryption HTTPS, and then configuring, registering the server directly in the Azure Site Recovery. So it's registering the server. And that's about it. And then it brings me back to the next step, which has to happen in the Azure portal. So I'm going to close my setup. I don't need my virtual machine anymore. And if all goes fine, then I have my configuration done. The next step is creating a storage account and Azure Virtual Networks, which is again just following a wizard, but I already prepared that one as well to gain a couple of more minutes in my demo. And then step 4, creating the protection group. A protection group is actually recognizing the already imported server. And from here, it recognizes my virtual machines on my Hyper-V box. Now, as you can see, the just a VM demo machine is not available here anymore because it was already protected out of the previous webinar I did. So let's say I'm going to select my Operations Manager virtual machine. It's a Windows machine and it's linked to this storage account that I created and linked to this specific Azure subscription. And then it will add the virtual machine. So just clicking away a couple of informative messages. So what I have now is my Hyper-V server is being recognized in Azure Site Recovery. My protection group is being created. Within my protection group, there's a connection with my Hyper-V server, from which I selected a couple of virtual machines. So in here, my server Hyper-V, there's the MockLab 2, which is my live server. The other one, for some reason, that's an older test, has a connection error, but that's normal because it's now overwritten with a newer version. So don't really worry about that one. So I'm going to the next step in my recovery process. It's actually building my recovery plan, where in the overall topology, so the Azure Vault, storage accounts, networking accounts, deploying the agents, the recovery plan is like the intelligence of the recovery process. You can create a new one or use an existing one. So within the recovery plan, it's based on different levels. So the first level is a group shutdown, performing a failover within Azure. And then the third step is starting the virtual machines. Now, as you can see from these option buttons here below, I can actually add additional tasks. For example, splitting up multiple groups. So a group can be, again, all domain controllers, all database servers, all application servers, or, I don't know, one domain controller, one application server, and one database server. Within any step, you have the option to add scripts. Scripts can rely on PowerShell, where you can create your own PowerShell scripts, or even relying on already community-built or Microsoft-built scripts that are provided within Azure already. A script, for example, could be, once my virtual machine in Azure starts up, you have to connect to my backend by using site-to-site VPN, for example, and copying 3 files from that specific file share. executing those files, and then continuing the startup. Or a script when virtual machines in Azure perform a shutdown as part of your recovery plan, that they need to execute an, ipconfig flush DNS, for example, or any other important tasks as part of your recovery plan. Now again, in the full ASR configuration, spend enough time with your customers or even within your IT department to actually write down the full recovery scenario. And if the group classification or the script automation is not enough, then you can also integrate manual actions, like perform the full failover, and at the end of the failover, just wait in the portal. And then there's some manual intervention needed to, for example, confirm the failover or any other manual process, like go out to the coffee machine and drink a coffee, then click OK to continue the recovery process. I also talked about the built-in monitoring. Or no, let me go to my recovery plan and then maybe just show you the failover. So a test failover, by using network integration or not, or performing a full failover. I'm quickly going to check if my virtual machine is already in a fully replicated state. Not really. Yeah. Let me first give you an additional advantage of Azure. Now, as some of you, I hope, already know, that Azure virtual machines are based on different machine classifications. Microsoft refers to them as t-shirt sizes. So one of the things that will happen is, based on your on-premises environment, Azure virtual machines will try to perform a one-on-one mapping. So like in this case, a single CPU and 2 GB machine on premises reflects a D1, a 1-core machine, and the 3.5 GB memory. So it's like the smallest machine available in Azure in the D series. Now again, one of the advantages, imagine in your on-premises environment, you're running a really beefy SQL server, 16 cores and 120 GB of RAM. Then during the ASR configuration, it allows you to perform or create a recovery virtual machine in Azure with other requirements. Like instead of having the full 16 cores and 128 GB of RAM, is replicate to a 4-core machine and only 16 GB of RAM. So you still have the application available within Azure during the recovery process, but it's not as performant as my on-premises environment. Or, and this is of interest if it's a bit harder to convince your customers or your CIO, CEO about the greatness of Azure, is actually performing a recovery machine or creating a recovery machine which is like 10 times the size as your on-premises environment. And then during disaster recovery, your co-workers, your CEO will go like, oh, Azure is really great as a solution. Look how fast the machine goes. And then somehow you're like playing with the Azure backend in that scenario. So the last thing, performing a failover. Now, for some reason, it's still replicating. Now, I'm just going to show you how easy it is to actually run the failover. A planned failover from on-premises to Azure, and even if you want, changing the direction, so performing a failback, executing, and the planned failover process will be executed. Now again, there's not enough time in this webinar to actually show you the full failover process, but what will happen now in background is the virtual machine, which was pre-configured in Azure out of the replication, will actually start up. It will synchronize the latest updates from the on-premises environment, replicating syncing with the Azure virtual machine. Once the Azure virtual machine state is identical to the on-premises environment, it will tell, again based on the sequence in your recovery plan, it will tell the on-premises server to shut down, and the virtual machine in Azure will start up. And then based on integration with site-to-site VPN, with maybe public DNS load balancing, the application server will become available to the end user. Now remember, the storage configuration and virtual network configuration in Azure, which allows you to specify IP addresses for your replicated virtual machines in Azure. So the job is running, and I'm going to show you the monitoring aspect. So these are my 7 or 8 steps in my failover process, and it's still in the pre-execution phase. Now on another layer, from a management monitoring perspective, it gives you detailed information for each and every step that happens in the environment. So for example, removing a server, disabling protection, a couple of tests that I did earlier today to make sure that my environment was healthy for the demo. Each and every step will be listed. If I go back for, let's say, like a week ago, then it's still the same. Everything that happened about a month ago, then it will provide you again full details. So for example, a couple of weeks ago, an issue happened in my failover. I select my failover process, and for each and every step in that specific failover process, it will tell me the exact explanation on what went wrong. So like in this case, data sync didn't happen, with detailed information on what was the root cause of that specific issue. Or as mentioned, on a lot of other layers, so from within the recovery vault, the dashboard selection, I can see the number of virtual machines, I can see the jobs in progress, successful jobs, downloading my agents, installing previous agents, verifying my certificates, and so on and so on. So I think with that, as I was talking about monitoring, it's about time I jump back to my slide deck and hand over the word to Stephen, who will provide you a quick introduction to Savision Live Maps.
Thank you very much, Peter. We're just going to take a minute or two for some shameless self-promotion and advertising before we jump back into the webinar. If you're familiar with Savision, we really hope that you're familiar with our flagship product, Live Maps Unity, which the features now that we base it around we call business service management. And we talk about business services, we really mean anything of value that IT provides to the business, disaster recovery being one of them. So if we just jump to the next slide for a moment. Really, when you talk about disaster recovery, there's 3 things you want to do. Number 1, you want to set it up. And Peter's done a great job showing you how to do that and how to get the failover going. Number 2, you want to make sure it's working all the time. And System Center Operations Manager provides a great platform for making sure that your disaster recovery is up and running. And also that when you do have to fail over to the secondary site, that the secondary site comes up and is operational as well. And then the third thing that you want to do, if you really want to show off how well the IT organization is running, is you want to show everyone in the organization how well you've got disaster recovery up and running and how the service is actually providing value to the business. So Peter, we can just jump to the next slide. So what we do in Savision Live Maps Unity is we allow you to take all these low-level IT components, your Hyper-V virtual machines, your physical servers, your Azure subscriptions, and we let you build them out into services that the business side can understand. And really what we do that is through a tool we really like to call distributed applications on steroids. So it's native distributed applications in System Center, but we give you the tools and the power to really make it easy. And we've had customers that take head-to-head competitions, System Center by itself versus Live Maps, 4 days to build a distributed application in System Center, 4 hours to do it in Live Maps. Once you have these business services built out, we then give you dashboards that you can distribute throughout the whole organization that give you different perspectives on the services. And we talk about 3 main personas. One is the end user. How does the end user perceive that application? Is it available is a big one. Is it performing? In terms of email, for example, are they getting emails? In terms of web pages, can you get to websites? Anything that really the business is counting on from a revenue and continuity perspective is lumped under end user. And the end user perspective, you can have your CIOs looking at, you can have your business service managers looking at, and so on. Then we give you IT-centric perspectives under applications, SQL Server that might underpin your application, IIS, and so on, and also infrastructure. There we talk about your switches and your networks, routers, and so on. And we show you the health of the business service at all 3 perspectives. And we also let you generate notifications at each perspective. For example, if something goes wrong from the end user view, if someone can't reach that secondary site, everyone needs to know about that and needs to know that IT is taking steps to handle it. On the other hand, if you have some redundancy built into your system, for example, you do have disaster recovery. If one of the sites goes down and the other comes up and everyone's still able to use it, you don't need to send notifications to the whole business. You don't need to turn everyone's little dashboard, as you can see in the slide, red. You just need to have the IT people know that something's happened and perhaps they need to step in and take a look. So really we like to have our different personas in this dashboard. Another thing we do is we actually integrate, and we'll look at on the other slide, with other systems as well. So we can take these business services that you've created and we can synchronize them into ServiceNow if you use that as your CMDB and your Service Desk tool. We can also integrate them into System Center Service Manager. So that your help desk people can look at any change request that comes in, any problem that comes in, any incident that arises, and see instantly what is the business impact. So now they're not just talking about server X or virtual machine Y, they're now able to say, well, this server, or this virtual machine, or this switch is part of this business service. And it really helps close the circle so everyone in the business can talk about things in the same way. Everyone can see when there are problems that should concern them and can ignore all the other monitoring noise. And if we just jump into the next slide, well, we've had these integrations for a while now for System Center Service Manager, for ServiceNow as well. In our next version, coming in early 2016, we're going to extend monitoring and not just look at Operations Manager, but we're also going to look at SolarWinds and then jump into other platforms as well. We know many of our customers have actually multiple monitoring platforms. They might use Operations Manager to look at things in Azure or on premises, but use SolarWinds for its network monitoring capabilities. And what we're going to give you the ability to do is create these distributed applications or business services that span multiple Operations Manager management groups, span Operations Manager and SolarWinds, and then future platforms as well. And you're going to be able to get notifications and end user infrastructure applications perspectives as well. So that's coming in the first quarter of 2016. Of course, Live Maps Unity is available today if you want to do business service monitoring and management and really show the business side of things, how on top IT is. And I think we've got a little demo of that. I'll hand it back to you, Peter.
Thank you very much, Steven. So for the last demo, I'm going to jump to my Operations Manager server. So from within the Operations Manager console, once you install the Live Maps plugin, it will actually give you additional information in the monitoring section. So one of the first ones is a overall dashboard, which can be configured in any way you want, giving you live information about the Azure state. So in this small environment, it's actually sending information back and forth between Azure, between my Hyper-V server, and the Operations Manager server. So as you can see, from an application perspective, everything is up and running. Azure services are fine. My Hyper-V server is running, but somehow there's something wrong with my environment. Now, you all know what's going on. Currently, the virtual machines are not fully replicated yet. So for him, it's being reported as an issue, as an alert within Azure Site Recovery. And that's the reason why one of the components are actually not green. Now, if I drill down and I want to get a more service-oriented view, then again, a couple of components will be green and some of them will be red. So again, some issues on my Hyper-V server. The agent is, I don't know, running out of time or whatever, but the overall management configuration of Azure Site Recovery is up and running. Or even based on more detailed views, application components with a specific state, infrastructure components with a specific state. And as Stephen already mentioned, all these dashboards can be tuned, can be tailored to your own specific needs. And again, LiveMaps is not only capable of managing and monitoring, providing you dashboard views on Azure Site Recovery, it's a full Operations Manager capable plugin, allowing you to create full dashboards for any Operations Manager component. So from the tool itself, it's actually pretty easy to configure. So you install the LiveMaps configuration tool. And from there, you can configure specific discover services, create services, import distributed applications. So it directs imports based on the Operations Manager existing distributed applications that you maybe already created before using LiveMaps. And then creating list views, creating dashboards. So if I go back to my Azure Site Recovery here, then it will contact my Operations Manager backend, providing me access to the management packs and management packs components, and actually allowing me to create my own custom created dashboards. So from a general perspective, specific views for the end user, infrastructure layer, service level agreements, which are relevant for service managers, like the number of nines of uptime of the full, in this example, Azure Site Recovery environment, how to manage notifications, what information do I want to get out of it, and the related services outside of, in this case, the Azure Site Recovery. So it's pretty intuitive to configure. Like again, in this example, importing the Azure Management Pack on the Operations Management server, installing the LiveMaps from Savision, then playing and configuring with creating of your dashboard views. It shouldn't take more than just a couple of hours. So I think with that, I hope I gave you enough information, first of all, about what is disaster recovery, about Microsoft disaster recovery solutions that existed for many years already and are still valid, then jumping to the Azure Site Recovery, and then doing a short introduction on the Savision LiveMaps tool, and ending with a small demo on how it looks like in your Operations Manager environment. So I don't know, Stephen, if you want to close up this webinar with some nice words and thanking the audience as well.
Well, thank you very, very much, Peter. For all of you watching, this webinar will be published online in a few days. We'll send notifications about that. You can also visit civision.com to download the companion white paper. Email us, sales@civision.com. We'd love to demo our tools to you. Or email info@pdtit.be if you want to send some comments to Peter. We do have some Q&A, and we've got a little bit of time left, so why don't we jump right to that. So the first question is about replicating VMware VMs to Azure. Is the minimum RPO really 30 seconds? The questioner thinks it was less than that due to the software they're using, a reference to InMage Scout.
Yeah, well, so what actually happened in relation to the InMage Scout? So the environment, as I showed you here, so the standalone Hyper-V or System Center Virtual Machine Manager, doesn't need anything else than just installing the Azure Site Recovery Provider, which I like to call the Azure Site Recovery Agent, on the Hyper-V server or the System Center Virtual Machine Manager. Now, if you're using a VMware setup or even a physical server setup, then there's some additional configuration needed, which involves deploying an additional virtual machine or two virtual machines in Azure and one local additional physical or virtual machine running the Azure agent as well. And then what actually happens from a technical perspective, the two Azure Site Recovery components from within Azure and the local environment will talk to each other, exchanging metadata information from your environment, and then checking, controlling, and executing the replication from your VMware-based virtual machines directly into the Azure Site Recovery, again by using HTTPS. So traffic going from a VMware virtual machine to Azure Site Recovery virtual machine allows you again to replicate up to 30 seconds. But then you need the additional control mechanism.
And 30 seconds is the minimum. We can't go lower than that.
No. So it's by default 15 minutes, can be lowered to 10, 5 minutes, or the lowest one 30 seconds, or the highest depending on the view you want to take.
Okay, and are we billed for Azure Site Recovery for the data that we transfer?
No. So yeah, actually a great question, because that's one of the things that I actually forgot to mention when talking about pricing. One of the reasons just behind or besides the technology why Azure Site Recovery, in my opinion, is a very good solution is as long as you're not really in a recovery state, so just using the configuration as the one that I showed you, then you're only paying a fixed fee for the service. And all pricing is available on the Azure portal in the pricing calculator. So it's a fixed fee, I think, close to $200 for just using ASR as a service, then $40 per secured virtual machine. And as long as you're not in a recovery state, so just using Azure as a backend where all the virtual machines are being replicated, then there's an additional cost for the storage consumption. Now, as long as you're not in a recovery state, so meaning you're not really starting up or running the virtual machines in Azure, that's the only cost there is. And then in a full recovery scenario, so imagine your full data center is down and you have to start up your 550, 500 virtual machines in Azure, and you're running them for 6 hours or maybe 2 days, then you will only pay the resource consumption for the time that they are actually running within Azure.
Okay. A question on network traffic. So if we do go to the secondary site in Azure or somewhere else, how do we redirect all our network traffic over there?
Yeah. So let's see if I can show it from the portal. So one of the settings you can configure on virtual machine layer. So in the meantime, it's synchronizing my operations manager server. So within the virtual machine configuration, once it's fully replicated. There is a topic here below mentioning the source and target network. So you can create virtual networks, and virtual networks within Azure are just a component, so it's not specific to Azure Site Recovery. It allows you to configure your IP subnets. So in this example, I have an address space of the 192.168.0 because in my local environment, I'm running the 192.168.10 as an IP subnet. So the first thing is creating your virtual networks in Azure. And then, of course, if you want to make sure that an end user can actually connect to your application, then it's or connecting to the public IP address of your Azure tenant, which is linked to your virtual machine, or by using a site-to-site VPN connection between Datacenter and the Azure backend. And then again, it's a little bit outside of Azure Site Recovery as such. It's just the way how Azure networking is working. So you can consider Azure as just another data center, like maybe a lot of you already have a second or even a third data center location today.
Okay, can I have the failover happen automatically without manual intervention?
Yes, that's a configuration setting within your recovery plan. Now, in most scenarios, again, it's disaster recovery. I would encourage you to not really rely on the full automated recovery process, because somehow, it's still a disaster recovery scenario. So it's not like a full high availability. So that's very important. It's disaster recovery. Because also the replicated virtual machines in Azure are down. So your on-premises environment, all VMs or physical machines are available. They are replicating the machine state to an offline VHD file in Azure Site Recovery. And then based on your recovery plan, you have to use some kind of magic or policies or verification steps by, again, for example, using PowerShell scripts. Like if a service on my local application server goes down, execute the failover process and start up the virtual machine in Azure. But that's part of your recovery plan.
So the VMs that are waiting in Azure for us to fail over, have we replicated the in-memory state of the VM or just the disk state?
Disk state and in-memory. So it's a full replica of the machine.
Is there any consideration for syncing of machines? For example, I have two machines, A and B. In my primary data center, A sends a message to B and gets a confirmation back. And so as far as A is concerned, everything's happy and B is happy. Then in disaster recovery, we fail over. Can I get into a situation where A in the secondary site thinks everything is good, but B in the secondary site never got that message?
Well, I wouldn't say it's not possible, but the way the replication mechanism works, as long as the replication state is not healthy, then the recovery process won't work. So if the replica between the data center and the virtual machine in Azure, so between A and B, is not in a healthy state, then Azure Site Recovery will never allow you to perform the failover, unless you explicitly confirm, I know there might be something wrong, and still execute my recovery.
Okay, and one final question. How much bandwidth is typically needed to sync the VMs to Azure?
Well, it depends a bit on the number of VMs. Now, one of the things that's been integrated since a couple of weeks, well, actually somewhere in summertime, is for the initial replication, it now allows an offline seeding service, which easily explained is you provide a SATA drive to the Microsoft guys. They ship them or they drive them to the data center. They upload your virtual machine copies, and then from there it starts replicating. So if you, for example, have, 100 megabytes of changes every 15 minutes, then you have to calculate the specific bandwidth you need to make sure that 100 megabytes in changes for all your VMs are capable of being replicated to Azure within the 15 minutes. So if you have like a 50 servers or 500 VMs, yeah, then bandwidth might be becoming a bit important. But I don't have any exact details like you need at least 1 megabit connection or a 2 megabit connection. It depends a bit on the environment.
Okay. Well, I think we'll bring things to a close. And again, thank you very much, Peter, for presenting this valuable information. And I'd like to thank to all the attendees, especially those who stuck around for the extended question and answer. Again, we'll have this webinar up on our website probably later next week. And we thank you all for attending. Have a great day.
Thank you very much.